Okay, children, so I hope you all watched the video full and completed your assignment. Completed your assignment, is it not? So please maintain your notebook very neatly. Ma'am, can you? Neatly, you know, I need not tell all this, is it not? You have to write it neatly, leave one line after each answer, highlight the main points. So after one full lesson, I will ask you to send your notes to my personal WhatsApp number, okay? So you'll have to update your notes and your lessons. Clear? Okay, fine. Now we'll start today's class. So today I am going to take plastics. So the name of the lesson is synthetic fibers and plastics, is it not? So we've already finished synthetic fiber. Now today we shall see plastics. So now plastics, what is plastics and what are the various types of plastics, all this will be seen today. Okay, so plastic is a material that can be molded into different shapes, is it not? So just like synthetic fiber, plastic is also a polymer. So what is a polymer? A polymer is a long chain which is made up of so many monomers. Many monomers combined together to form what is called a polymer, and that process is called polymerization, is it not? So plastics are also polymers. They are also long chains made up of many monomers, and each monomer is a chemical substance. Okay, so plastic is a material that can be molded into different shapes, and plastic is a polymer. Now look at the various things that can be made of plastic: chair, buckets, pipes, brushes, toys, and many household items. Right from the morning you get up till you go to sleep in the night, you just make a list of the number of things that you're making, that you're coming across with plastic. So plastics is a part and parcel of our life. So to study about plastic is also very, very important. So we should know some of the properties of this plastic. Okay? So plastics can be classified into two. They are thermoplastics and thermosetting plastics. So now what is these two? We'll be just seeing with some examples. Okay. So what is thermoplastics? Let us see first. So thermoplastic, look at this example. Now this is a block of plastic. This on heating, it melts and it softens and it changes into, we can change that into various shapes. You make a shape like this, and after some time you feel that this shape is not proper, then again you can melt and you can make another shape, and like that you can heat and melt it a number of times like this. Okay, so such kind of plastics which can be softened on heating and can be remolded and reshaped a number of times is known as thermoplastics. Okay, thermoplastics. So a plastic which can be softened or which can be melted on heating and can be remolded and reshaped a number of times. Now on the other hand, there is another type of plastic, that is thermosetting plastic. Now look at this. Once you heat and you make a article, then that cannot be heated or melted a second time. So such kind of plastics are called thermosetting plastic. So thermosetting plastics are plastics. One set, when heated, one set cannot be heated again and remolded or reshaped a second time. So such kind of plastics are called thermosetting plastic. From the word itself, once it is set, you cannot change the shape again on heating or melting. Okay, clear? So examples are shown here, and what is the difference between this? The main difference lies in the structure. So this is the structure of thermoplastic. I told you plastics are polymers. So they have a linear polymer chain. In the case of thermoplastic, they have a long chain with many monomers. So that is the main difference. And thermosetting plastic, why it cannot be melted and heated a second time, is because of its cross-linked arrangement. Okay, they have a cross-linked arrangement of monomers, and they are very intact and they are fixed. They cannot melt on heating a second time. So the main difference between thermoplastics, why it can be melted and why thermosetting plastic cannot be melted, the reason is because of their structure. So in thermoplastic we have a linear structure, and in thermosetting plastic we have a cross-linked arrangement of monomers. Okay, that is a structure. Okay, so definition. Okay, plastics can be classified into two: thermoplastics. What are thermoplastics? A plastic which can be softened repeatedly by heating and can be molded into different shapes again and again is called thermoplastics. Thermoplastics are also known as thermo-softening plastics. Okay, they are known as thermo-softening plastics. Examples: polythene and polyvinyl chloride. Polythene and polyvinyl chloride are examples of thermoplastic. You are very familiar with polythene bags. We go to a market with the polythene bags to buy vegetables and all. So that is actually polythene, and it is a polymer. It is made up of ethene molecule. Many ethene molecules combine together to form polyethylene, and in short we call it as polythene. Okay, then polyvinyl chloride, it's a full form for PVC. So that is also an example for thermoplastic. Now, where is it used? These are used for manufacturing toys, combs, and various types of containers. So I hope it is clear. Next, what are thermosetting plastics? A plastic which once set does not become soft on heating and cannot be molded a second time is called a thermosetting plastic. Thermosetting plastics are also known as thermosets. Example: bakelite and melamine. So bakelite and melamine are examples for thermosetting plastic. Now bakelite is a poor conductor of heat and electricity. So it is used in making electrical switches and handles of various utensils. Okay. So bakelite and melamine, it is a fire resistant plastic. It is used for making floor tiles, kitchenwares, and fabrics which resist fire. Okay, now let us see the structure. Now you understood the definition, now you know the example. Next we shall see the structure of these two plastics. What is the difference between thermoplastic and thermosetting plastic, we shall see. So the difference between the two, I told you already, lies in their arrangement of units in their structure. So see, in thermoplastic we have linear arrangement of units. Linear means we have a long chain in a straight line. We have straight chains. Okay. So in thermoplastic, the long polymer in thermoplastics, the long polymer chains are not cross-linked with one another. Due to this, on heating, the individual polymer chains can slide one over the other. This makes thermoplastic soft and capable of melting. Okay? So there are many chains lying straight one after the other, and when you heat, what happens? Since it is not cross-linked, they can slide one over the other, and because of this sliding they can melt. That is why thermoplastic melt on heating, and we can change its shape any number of times. Okay. Now coming to cross-linked arrangement of units as in thermosetting plastics. So this is a cross-linked arrangement. You can see the structure. They are attached to each other. They are not in a straight line. So we have a very big chain of this kind of polymers. Okay, it's a very, very large unit. Many monomers are combined to form very long chains. So in this structure, since it is very intact, they cannot slide one over the other on heating. So as a result, it will not melt. Once set, then it will not melt the second time. It's mainly because of this structure, cross-linked structure. They cannot move or they cannot slide one over the other. So see the explanation. In thermosetting plastics, the long polymer chains are cross-linked with one another. This cross-linking prevents the sliding of individual polymer chains on heating. Due to this, thermosetting plastics do not become soft on heating once they have been set into a particular shape. Okay, so when you write the answer for this at the end of the lesson, I have end of this slide, I have given some assignment questions. So I have asked you to write the difference between thermoplastics and thermosetting plastic. So that time you must write the definition and you must draw this diagram and explain about the structure also. Okay. Now Teflon, that is another kind of a special kind of plastic. Now Teflon is actually, you look at this picture, you can see this in your kitchen, is it not? Your mother cooks food in this pan, non-stick pans. So this non-stick pan have a coating of Teflon on it. That is actually a special kind of plastic. Now what is the chemical name for this Teflon? Polytetrafluoroethylene. Okay, so just by heart that chemical name. Write the chemical name of Teflon means it is polytetrafluoroethylene. Now it is a special plastic on which oil and water do not stick. So it is very comfortable to use this non-stick pans in the kitchen because the food materials will not stick to the pan, is it not? It is actually made of iron, but a coating of Teflon is given on top of it. As a result, we need only very less amount of oil as well as the food will not stick to this pan. Okay, so that is Teflon. It is used for non-stick coating on cooking wares and it can withstand very high temperature. So that is the main characteristics of Teflon. It can withstand very high temperature. So that is a special kind of plastic on which oil and water does not stick. Now another, melamine. I already told you melamine is an example for thermosetting plastic, is it not? So it is used to make fireproof plastic. So the uniform of firemen, look at this picture. Fireman uniform, actually there is a coating of melamine plastic on it to make them flame resistant. And it is a fire resistant plastic. Now coming to the properties of plastic. So I hope this much is clear. So plastics are mainly classified into two, thermoplastics and thermosetting plastics. Thermoplastics means they can be softened and melted a number of times. Example is polythene and PVC. Thermosetting plastic means once it is heated and once it is set, you cannot reshape or remold it a second time. So such plastics are thermosetting plastic and the main difference lies in their structure. In thermoplastics, we have linear arrangement of units, whereas in thermosetting plastic, we have a cross-linked arrangement of units. Okay. Now coming to the properties of plastic. There are so many useful properties of plastic. So let us see a few useful properties of plastic. So first point, they are chemically inactive. They are not very reactive. For example, you see two chairs. One chair is made of a metal and the other chair is made of plastic. And you keep these two chairs exposed to atmosphere or exposed to air for few months. And after 1 or 2 months, if you just observe, you can see that a chair made of metal or iron started rusting, whereas plastic chair remains as initially as we put it outside it in the first time itself. How we placed it there, it will be just like that. So that is the main property of plastics, very useful property of plastics. So that is why it is used to make number of things, okay, with plastics. So it is non-corrosive, or it does not react with the gases present in air or water present, moisture present in air. So it is very, very durable. It is unreactive. It is inactive. So they are chemically inactive. Metals like iron get rusted when exposed to air and water for a long time. This is because metals are chemically reactive. Now, second point, plastics do not react with air and water. Due to this, plastics are resistant to corrosion. In other words, plastics are not affected by weather. So it is considered as a very important property of plastic. That is why it is used to make various articles. Plastics are also unaffected by various chemicals like acids and bases. So they are used to store chemicals and water. Okay, that is the first point. Now coming to the second property of plastic. It is a poor conductor of heat. So see this picture. Plastics are poor conductors of heat. So as a result, the handle of cooking utensils are made of plastic. So why this continuously coming? Okay, so plastic is a poor conductor of heat. The the utensil which you use in the kitchen for cooking, actually the middle part is made of metal, whereas the handle is made of plastic. If the handle is made of metal, what will happen? You won't be able to touch it, is it not? Because it conducts heat. Metals conduct heat. So as a result, the handles of utensils are always made of plastic. So that is another property of plastic. That is another property of plastic. Plastics are poor conductors of heat. So they are used to make handles of utensils. So the middle part where cooking is taking place, there it should be made with a metal. Otherwise, if you cannot make the whole thing with plastic, because that is it will get destroyed, isn't it? So the handles alone are made of plastic, so that because it does not conduct heat. Hello. Students, please don't annotate, okay? So that is why that option is coming continuously on the screen. So please don't annotate. Okay, so the second property of plastic, it is a poor conductor of heat. It cannot conduct heat. As a result, it is used to make handles of utensils. Now next, plastic is a bad conductor of electricity. So electricity, you know, it is a very useful thing, and it is used to run many electrical gadgets at home, like mixie, a TV, refrigerator, and many items, isn't it? So a plastic, now look at this picture. This is a wire, isn't it? It's a metal wire, and it is given a coating of plastic. If there is no coating of plastic, what will happen? You will get electric shock and you may die. So always a plastic coating is given over electric wire. So that is a very important use of plastic. So plastics are poor. Why is it done like that? Because it is a poor conductor of electricity. That is why we are able to give a coating on this electrical wires. So plastics are poor conductors of electricity. So it is used to give plastic covering on electrical wires, and handles of screwdrivers are also made of plastics. Now coming to the next very important property, plastic is light and cheap. At the same time, it is strong and durable. Okay, so now look at this picture. There are two. One is made of a metal and this is a plastic rod. Now, metals are heavy, is it not? But plastic is very light to handle. It is very easy to handle plastic materials. And also, it is cheap. Metals are little expensive, but plastics are cheap. And at the same time, they are strong and durable also. Plastics are strong and durable just like metals. So, most of us prefer, many of the things are made of plastics. Now, another important property, plastic can be molded into different shapes. See, the number of items, not only this, if you make a list, the list will be endless, is it not? You can make a number of items using plastic, chappals, slippers, mugs, combs, toys, and many more. Okay, so plastic can be molded into different shapes. So these are the properties of plastic. So plastics, what are the main properties? First of all, they are inactive or they are not reactive. They do not react with air or gases present in the atmosphere, and as a result it is used to make a number of items. Okay, now second, what is the second property? It is a poor conductor of heat. Because it is a poor conductor of heat, it is used to make handles of utensils. Now third property was it is a poor conductor of electricity. So it is used to make, it is used to give a coating over the electrical wires, and also handles of screwdrivers are made of plastic. Now then fourth, it can be molded into different shapes, and so you can make a number of items with plastics. Okay, so these are all the properties of plastics. So I hope you understood. So assignment, answer the following question. You have to write these questions neatly on the notebook. Explain the difference between thermoplastic and thermosetting plastics. Give example. Okay, so let me ask